start recording. And if you have a question, you can just either type it into the chat or you can raise your hand and then ask away. Otherwise, I'll just kind of review a couple of things that are important to know for this test, and maybe work through a heparin protocol question. The review packet you got, this should be the same packet or similar packet. This is just from the spring, was it spring 2024? I don't think it's changed too much. Practice your conversions. They're, sometimes you get a little bit too confident that you know how to do those and you make some mistakes. Just make sure you practice that just to be on the safe side. Review some of the things that you've done many, many times. Keep in mind that you want to pay attention to your conversions and the units that you're using. I worked through these last time because this is kind of the new stuff. This number 11, the dopamine infusions, where you're going from micrograms per kilogram per minute to milliliters per hour. And so I worked through those. And you can just watch that again, so I don't have to rehash what I already did. And I did work through both those examples. So these were probably even more intense than what you're going to be responsible for, but it's there to look at. While I'm here, I'll do this clonazepam one. I don't think this is necessarily a tough one for most everyone. It's just a variation of reminding you that when you have micrograms listed and then your milligrams is what's available, you just want to convert one or the other. So I either want to convert this to 0.25 milligrams, or I want to convert this to 250 micrograms. You get to decide which you want to do. Just make sure they're both the same when you do the math. But no matter how you dice it up, the answer would just be 1. Okay. Yeah, here's another one very similar where the challenge is the orders in micrograms, but the availables in milligrams. So if I take my order in micrograms over and I convert the available into micrograms as well, that's what I want to do. Okay, times my tablet, and then I get 1.5 tablets, and then they probably want you to write it as like this, 1.5 tablets. I don't know that definitively, but you always double check with your instructor if they want you to write half as 1/2, or if it's okay that you have 0.5. Just make sure it's clear. You may want to just write both just to be on the safe side. Let's see here. Most of these I think you're pretty good with because you've done these enough times where you've done your IMs and you've calculated your milliliters. Let's do a couple of these infusions. So this says calculate the number of hours for a 420 milliliter solution or CC solution if it's infusing at 120 cc's per hour. So what you want to do is you want to take your total, the 420 cc's, and you can do it doing ordered over available. I'm just going to do it doing dimensional analysis, 120 cc's per hour, and then 420 divided by 120. It tells me that it's going to be 3.5 hours. So that's how long it'll last. Sometimes they want you to write that as 3 hours, 30 minutes. So it really just depends how they want you to write that out. I don't know the answer to that to tell you like this is how to do this or that in a particular way. I would just say just ask. That way you're not guessing. Oh, go ahead. Question 9, sure.
Okay, so if they said to calculate hours in, oh, I'm sorry. I put my hand up. I thought you were talking to me.
No, go
All
ahead,
right.
Rachel. Yeah, no, go ahead.
Okay. So it says calculate the number of hours and minutes. Would it be like 3 hours, 30 minutes, and then 210, or like 3.5 hours versus, and then also 210 minutes? Because in
Uh, uh,
my, sorry,
no, you're fine. Go ahead.
I wasn't sure if they wanted hours and minutes, like
So,
two answers.
yeah, my assumption is if they tell you in hours and minutes, like they want their answer in hours and minutes, then they want it. The way I interpret that is 3 hours, 30 minutes, not
Perfect.
not 3.5 hours or 210 minutes. I don't think that they mean that. So
Okay. Thank you.
yeah, that no, that's a great question because um I do, yeah, I think they just mean either they want you to write it as 3.5 hours or three, like you said, 3 hours and 30 minutes. So I don't think they usually care too much if they don't tell you specifically, but this does say his number of hours and minutes. So I think I would go with this answer. The 3 hours, 30 minutes is the total.
That makes more sense now.
Yeah. All right. Number 9. All right. So number 9, this is that you've done this one now since first semester. This is just um it's just a fluid replacement. So I'm gonna tell you, like, I'll just kind of label some things and then I'll tell you how to kind of pay attention to what you're looking for. But so what we're looking at is what this question says. So it says for every 150 milliliters of urine output, we want to replace with 40 milliliters of water. Okay. So for every 150 out, we want to put 40 back in. Okay. So that's kind of like the the mechanism here. Then it says the actual output is 600 milliliters. So what did they actually void out? It's 600. And so we want to know, what are we doing? So the actual was 600 out, and we want to know how much to put back in. Okay. So I'm just kind of brainstorming and writing out some numbers before I kind of put things together. The way I have told, and I think I even wrote up a like kind of like a practice or like a formula for this. And then what I've told students to do is take whatever the patient actually voided. So the 600 is what they actually voided over kind of the expected output. So you're basically just comparing your outputs to one another. So your actual output over your expected output and just multiply it by the replacement volume. And if you do that every single time, you'll get the right answer every single time because um, it's basically equating these things. And I'll show you what I mean by that in just a second. So if I take the 600 over 150, so 600 over 150 is 4. So 4 times 40 is 160 milliliters. Or just plug it into your calculator where you take 600 times 40 divided by 150. And then, like I said, you'll get the same answer, 160. So what I did was I said, what's the multiple from going from 150 to 600? Okay. So what's that multiple? It's times 4. So that's the same multiple I'm going to use to calculate this. Okay. So it's just a way to, you're trying to relate the information. I can do the same thing for here where I have, it's the same replacement, right? 150, 40, but this time the output is only 100. So the actual output is less than the expected replacement volume, but I'm still going to do the same setup. I'm going to put my actual output over my expected output times my replacement volume, and I'm still going to get the same answer, or I'll get the same correct answer doing it this way. So if I do 100 times 40 divided by 150. I'm going to get 26.6 repeating. So this patient would just get 26.7 milliliters. I don't think you're going to see a question like this. I think it's going to be more so, it'll look more like this. I just put this here so that for practice purposes, so that way you know to what to put where. Because if you reverse these numbers, you'll get an incorrect answer. So good question. All right. Another flow rate. Oh, yeah, this is what I was starting to work on. Flow rate question. Um, it says we have an IV of 500 milliliters infusing at 120 milliliters per hour. We have a drop factor of 15, and we want to know the drop rate. So this is one of those questions where there's extra information that sometimes you could start to use the information that you don't need. And that extra information is we don't care what the total IV is for answering a rate question. The rate question is just how quickly is it going to go through that 500 milliliter, 250 milliliter. It really doesn't matter what the quantity is. What we need in order to calculate a drop rate is we need the flow rate, which is 120 mil per hour, and we need the drop factor. Okay, and we have those two pieces of information. So it's 120 milliliters per hour. Now, because I'm looking for per minute, I'm just going to convert minutes to hours right here, and I'm just going to put 60 minutes times my drop factor. Before I do anything, I'll make sure before I do the math, I'm in the correct units. Drops are on top, minutes are on bottom. So I just need to multiply across the top, divide by the bottom, or reduce this to 2 times 15, and I'd get 30 drops per minute. And I'm going to do the same thing for the Ringer's lactate question. You have 180 milliliters. Ringer's lactate is supposed to be diffused or infused over an hour. So that's the same thing as 60 minutes. So this answer actually even is the same as this. It's going to be 30 drops per minute again. Oh, in case you see this again, remember, they're going to ask you these questions where you're going to have to look at your regular insulin and then your NPH. So the solution amount to be drawn up first, 22 units of regular first. And then the total is just adding those up. So that's 58 total. So when you're marking your syringe, so first of all, choose the correct syringe. My total's at 58. Hopefully you write better than I do. So 58 units total. You don't have to write the number 58. Just make sure you're marked correctly at the 58. And then if you recall from this, because you draw the regular insulin up first, it's going to be closer to the 58 mark. So you're just going to make a mark at 22 units from 58, which happens to be the 36. So you're just going to make another mark here. And then you're supposed to know that that is your regular insulin in this area here. This is your 22 units of regular insulin. And then your NPH is down here. And then I have a example of how they what the textbook shows, how they're wanting you to write this. If you go in the shared OneDrive folder, it's right there. It says mixed insulin syringe, and it just gives you a breakdown of how this should look. So if I'm writing my 2 arrows, I might actually also just make sure I include that the regular is in this area and the totals here. You shouldn't have to worry about that because they just tell you to do 2 arrows. They just want you to mark the first arrow, or one of the arrows being total and one of them being the regular insulin mark. And that's how you would do that. I didn't get to go through these last time, but this is what you saw in 230. Some of these flow rate questions with the heparin. And so I'll work through these two here. So what this question is asking you to do is take units per hour and convert it to milliliters per hour. So they're just asking you to make a conversion. Kind of like if you were going from the US to Canada, you go from miles per hour to kilometers per hour. There's a conversion that's there. Sometimes the vehicle just takes care of it, or it's already like there on your either your digital readout or your analog readout. But anyways, just giving you an example of where that might come into play. So my methodology is to take, or my strategy is to take the original flow rate and then convert the units per hour by getting rid of units and converting it to milliliters. And I can do that because I have this IV that has the 25,000 units of heparin and then a 1 liter bag of dextrose 5% water. So that's one whole IV. That's all together. So I can take my 1,000 milliliters, my 25,000 units, and then I can calculate the flow rate of that. So I'm going to take this 750 times 1,000 divided by 25,000, and I'm going to get 30 milliliters per hour. So this is something you do when you do the heparin protocol. Remember, in the heparin protocol, it'll tell you to infuse at like 18 units per kilogram per hour. You multiply by the patient's weight, and then you're in units per hour, and then you just need to convert to milliliters per hour. So this is kind of like a practice part of the heparin protocol when it asks you to calculate the infusion rate. Let's look at 26 too, just for extra practice. So again, I'm going to start with my initial infusion rate of 1250 units per hour. I'm going to multiply by, with the intent of getting rid of units and converting it to milliliters. So that's what I did here too. 500 milliliters, 25,000 units. And then I just plug it into the calculator. 1250 times 500 divided by 25,000. And I get 25 milliliters per hour. So there's a couple, you can do this any number of ways. That's just, some students like to start with the milliliters on top. Just make sure wherever you put your milliliters that it stays consistent with what's in the IV. Okay, because the IV, you can't separate the IV, right? So like I always tell students that, for like question 26, here's your IV. It's connected, it's up on the pole there, it's connected to tubes, connected to the patient. And then this is you know, this is a 500 milliliter solution that has the 25,000 units of heparin. So you can't separate them. They're in the same thing. So what I can do is I can say I could put 500 milliliters on top, 25,000 units on bottom, or I can reverse that and put 25,000 units on top, and then the 500 milliliters on the bottom, depending on how we're needing to set that up. All right, so let's look at the heparin protocol. So I wrote this out last time. I talked about how and reminded you, because you saw this last semester, that the standard weight-based heparin protocol is all these steps 1 through 15. Um, and then I highlighted what's important for answering the questions. And then I crossed out the other things that are not important for answering these questions, because we're worried about the math. We're not worried about the actual protocol and procedure, which is why I rewrote it in a different capacity in the segments below, and then that way we can kind of see that and look and see what that looks like. So let me go to that, what I hope to maybe eventually convert these into. So this is ideally what I'd like to get it to, where your question looks more like this, where you have the patient's weight in pounds and you have to convert it to kilograms. Then you have an order and you have an available. It asks you to calculate the bolus, and then it asks you to calculate the infusion. Okay, so let me work through this just for extra practice. So step one is we got to convert pounds to kilograms. So 220 pounds ends up being 100 kilograms. You just take 220 divided by 2.2 and you get 100 kilograms. So my 100K kilogram patient, I'm calculating my bolus dose. So I'm going to follow the bolus dose, 80 units per kilogram. Crosses out. And then I want milliliters. So this is where what we were doing in the previous questions, where we were converting units per hour to milliliters per hour. Well, now we're just going to convert units to milliliters. So we want units here, milliliters down here. I'm going to look at my available. I have an IV, and then I also have a bolus. Since we're calculating the bolus and we're looking for milliliters, we'll go ahead and use the bolus dose information. And then this will come out to 8 milliliters. And I know that because 100 times 80 is 8,000, and then divide by 1,000 is 8, or plug it into your calculator and you get that same answer. Go ahead, Rachel.
Sorry. That is much simpler. I remember yesterday or Tuesday you were talking about this. It looked complicated, but you just going through it made it's much more simple.
Good. Yeah, I don't intentionally try and make it more difficult. I just trying to, like, when we look at this, because unfortunately this is probably what you're going to see, is without all my writing and without the highlighting, you're going to see the whole protocol. So I'm trying to get you to narrow down on focusing on what you are responsible for, which is why I created these more kind of direct questions where you would just go right to answering the question by breaking it down without having to worry about all the extra information that's there. So, but yeah, this is all you're looking for. You're just looking for what's the order, what's the available, and then for both the infusion and the bolus, and then just practice, practice, practice. For the infusion, you're going to take the 100 kilograms. My infusion rate is 18 units. Kilogram hour. Kilograms are gone. Again, we don't want units per hour. We want milliliters per hour. So all I'm trying to do is convert units to milliliters. Now we're doing a infusion rate with an IV, and those are the clues to use the IV information. So bolus, use the bolus available. IV, use the IV available. So 25,000 units, 250 ml. I think that's going to be 18, but let me check. So 100, yeah, it's going to be 18 times 18 times 250 divided by 25,000. And that'll give me 18 mil per hour. If you, since you can see what I've written up here, go ahead and try this 147-pound patient, and then just type your answers into the chat, see what you get, just for the practice. And if you've already done it, just wait, or just go ahead and answer it. Just put your answers down, and then I'll just give you a couple minutes to work through that and make sure you can do it. Rachel, I'm not sure if you raised your hand again or if that was still part of the
I did.
earlier. Oh, okay,
And
go
this
ahead.
probably is stupid, but like whenever I converted the weight or, to kilograms, so it was like 66.8181. Should I round like 66.82?
So remember when we're doing our rounding rules, we want any number greater than 1 round to the nearest tenth. So
Okay, so
round it to 66.8.
okay, thank you.
You're welcome. Yeah, in reality, like, because you still got the same answer I got, the 5.3, so
Okay,
that's not, you did it right. So even if you don't round and you wait till the very end to round, we should all get the same answer.
okay. I'm gonna do the next one.
Okay, go ahead, take your time. Yeah, good. I'm not sure if it's Mia or Miar, but yes, that's what I got to.
It's Maya.
Maya, thank you. Okay, sorry. See, I have no idea.
I wrote it weird. I don't know why it defaults to that.
That's okay. Yeah, it's well, I mean, even if it just yeah, I don't know. So, but yeah, okay. Well, thank you, Maya. Yeah, you're good. Yeah, that's exactly what I got to. So, I'm gonna write these out too. So the only thing that might change with this is if they were to give you the um like, let's say if in the previous, like, the full protocol where it gives you the additional, like, after the APTT, we get a different time, so it might tell you to, the order might be to rebolus the patient with 40 units per kilogram, and then to increase the drip rate by 2 units per kilogram per hour. In order to answer that question, though, you need to know what the original one was, so it would be given to you within the context. Meaning, the patient has been on 80, or started with 80 units per kilogram bolus, and then has been on an 18 unit per kilogram per hour drip. Um, After 6 hours, we want you to rebolus with 40 units. So our new order is 40 units per kilogram per body weight, and then increase the infusion rate by 2. So you would just go 18 plus 2 to 20 if they gave that to you. I don't think that they will, but if they do, now you know.
I was wondering because we have to do the ATI modules before this,
Mm-hmm.
and I don't know if it just like couldn't be put on ATI, but this wasn't on here at all. Like, do you know if this is something we're definitely going to have on the test?
The heparin?
Yeah.
Yeah, because you had it last semester too. So you'll definitely have the heparin protocol on your test. Yeah, I don't know. Like, this, like, what's written here, like, this is part of your packet. I just added these um here. So if you review your packet, you should see these questions still here.
Yeah, no,
Um
they were here. It's just they made us do another thing for ATI, and they said
okay.
that those questions are also going to be possibly on the exam. So it's just a lot of different, I don't know, different material. So just wasn't sure.
Okay.
But I
Yeah, I
did
think,
both.
and I do think yeah, and I would say practice both, um and just make sure you're practicing both so that you're, like, covering all your bases. The ATI material should kind of coincide with this. I don't think you're going to see too much of a difference from what, like, you're seeing in these question types here, because these have been typically what we've used on previous exams. So I think you're going to still see a similar setup that looks more like this than it looks like the ATI, but there's a lot of overlap.
Okay. And then I know it's silly, but number 29. So the entire syringe is the 1 milliliter, correct?
Right.
So it would
Yeah.
just be
So
at the 0.50 mark.
correct. Yeah. So
Okay.
like, yeah, this one is like it's the 4M, 8M, 12M. These are molar units.
Okay.
And it doesn't clearly state that this is a 1 ml syringe. My assumption is you're supposed to, well, yeah, it tells you mark the dose on the 1 ml syringe. So you're
Yeah, the
supposed to know that
molar
this is
thing, it
1
just
ml.
threw me off a little bit.
Yeah, I think because if you pay it, it's kind of like a ruler, right? A ruler has inches and centimeters on it, or inches and
Yeah.
millimeters on it. And so they're showing you like this is what you have to kind of decipher and pay attention. And what they're looking for is, do you know to choose the 0.5 ml versus one of these other increments? Like, and hopefully you're not choosing any of those numbers.
Yeah.
Yeah.
Okay.
Yeah, good question. All right, let me finish working through this here. For the second one, again, 66.8 times the 18. And then the 250 ml, 25,000 units. And then before I do anything, I just make sure everything crosses out. You do not need to, oh yeah, it's per hour. You do not need to do exactly everything I'm doing. That's just kind of my procedure. So I'm double checking my work as I go along. And then if you ever miss something, sometimes it's helpful. Oh yeah, that's right. So we round it and we get 12 milliliters per hour. Did you get the 12 milliliters per hour, Rachel?
I was struggling because for some reason I didn't see the 250 ml, but all my steps are correct until I got there and it held me back. But I got it now.
Okay. Do you see it here now?
Yeah.
Okay. Yeah, like I said, a lot of that is just practice, 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 and then it'll stick the more you practice it. So all right, well, that's kind of the bulk of the stuff that, that I would say like kind of the more hard or challenging stuff that you'll have to deal with. But go ahead and look any of the question numbers. If you want me to work through anything, just let me know. If you feel pretty good about everything, you can always email me between now and your test. But I'm here. Just ask away if you have a question.
I have one question. Can
Go
you
ahead.
scroll up to the military time one?
Yeah.
Okay. I just want to make sure. So basically, I think it was, I don't, the 500 ml you divide. So it's like, will you go to the question? Sorry. I only have my notebook real quick. Oh, you are there. So you would divide 500 milliliters and 125 milliliters and you'll get 4. So then
Yep.
does that mean 4 hours that you add on from 7:30?
Correct.
Okay, so then it'd be 11:30.
Correct.
Okay, I know. I was like, I texted Danielle and I'm like, she's like, today she got back to me and she's like, okay, I think I figured it out because I completely overcomplicated it, but I appreciate it. Thank you.
You're welcome. Yeah, I think that like let's say it started at like let's say it started at 11:30 and you're adding the 4 hours. What I usually do is I just add that as 400 and that'll give you the 15:30. So that's one way of doing it. Or like I would just say, okay, 11:30 and then I'm on my fingers 12:30, 1:30, 2:30, 3:30, but they want it in military time, right? So that's just another way to kind of do that.
All right, perfect. That's all I have. So go take a break before your next meeting.
All right. No, sounds good.
All right,
Yeah,
thank you.
if you need anything, just email me and good luck on your test.
Thank you. Take care.
You're welcome.